Welcome to Microsoft Build 2017. My name's Rick Manning. I'm a program manager on the Windows graphics platform. And today I'm going to show you how you can use some exciting new features in the Universal Windows platform to bring SVG images to your app. So if you're watching this video, then you're probably already kind of interested in using SVG images. But just in case you're not a fan already, let's quickly go over some reasons why SVG is a great format for iconography. So let's say you're making an app, and your app has a lot of images. Well, maybe your UI has a lot of custom icons, for example. One common way of implementing that would be to use traditional raster graphics, bitmaps. If you go down that path, though, you're quickly going to run into some challenges. For example, if you want your images to display perfectly across a wide range of devices, you're going to need to provide multiple sizes of each of your assets to avoid scaling artifacts when you're running on higher or lower DPI systems. If your app supports user themes or high contrast modes, then you might need to supply even more versions of your assets, since raster graphics aren't easily modifiable at runtime. All these versions add up to some hassle and typically a lot more disk space consumption too. That's where vector graphics comes in. SVG is the de facto standard for vector imagery these days, and they're great for several reasons. Because vector graphics are defined mathematically, one image can be scaled to any size without loss of quality. That means a single file can serve all of your scale factor requirements. Because they're built on an object model that can be accessed programmatically, SVG images also offer some advanced iconography functionality. For example, custom theming, animation, and so forth. These are some of the reasons why SVG has been gaining popularity recently, particularly online. Unfortunately, it's historically been pretty challenging to use SVG images in your native UWP apps. That's why with the Creators Update, we're excited to announce built-in support for SVG images. So what does this mean for you specifically? Well, if you use XAML, then the image control that you already know and love now supports SVG images exactly the same way as it supports raster graphics. If you use Direct2D, you now have access to powerful new APIs that let you load, manipulate, and render SVG images programmatically. Both of these features are built on a new high-efficiency rendering logic that's built into the graphics platform. It's built on DirectX, so you get hardware-accelerated performance without the overhead of a browser engine. We're also working on bringing this functionality to Win2D. So for example, if you're a C# developer using XAML, but you still need to do that low-level 2D custom rendering, this is great news for you too. Expect that coming sometime this summer. I should also mention that we still support the methods of rendering SVG that you might already be familiar with. HTML apps and the XAML WebView control are both based on Edge's full browser-grade support for SVG, and they also offer access to JavaScript. So if you need that kind of functionality, we recommend using those technologies. OpenType SVG fonts, which we introduced in the anniversary update last year, allow you to use SVG to define the shapes and colors of glyphs in a font. This lets you implement rich, multicolored font for text scenarios or for icon fonts, if that's how you prefer to manage the icons in your app. So with that, let's get into our first demo. For this, I'm going to show you just how easy it is to use XAML to bring SVG images into your app. So what I have here is a blank C# XAML app. This is just the project that you get if you create a new C# app in Visual Studio. I also have an SVG image that like you could create in Adobe Illustrator or Inkscape. Just a happy little smiley face. So let's get the smiley face into our app. To do so, we're going to follow the same set of steps that we would use if this were any old PNG. I'm going to start by adding the asset to my app package. I'm going to use the Add Existing Item dialog, find the asset on my hard drive, and add it to the project. It's showing up in the Solution Explorer now. I can double-click it, and there's the XML-based syntax that you're used to seeing. Returning to our main page.xaml file, let's actually get our app rendering this asset. To do so, I'm just going to toss in a simple image control. I can point this image control to the asset that we just added, drawing.svg, and I'm going to give it a default width and height. If I left off the width and height, this app would scale the SVG dynamically based on the layout engine in XAML and how it determines the image control needs to be sized. We also offer a new SVG image source control if you need to use more advanced image source-based scenarios, like using SVG as the backing for a brush. So let's run this. And with any luck, if I haven't made any typos, we should see a nice, simple app with my smiley face in the middle. Here it comes. And there we have it. That was a cinch. OK, before we get into our next demo, let's take a moment to talk about some of the specific functionality in this new SVG implementation. For this release, we really wanted to deliver a focused, tight implementation of SVG that's perfect for your in-app iconography. You might know that SVG is capable of much more than simple images, but to keep our implementation efficient, we scoped it down to that really core graphical component of SVG. That means that some advanced scenarios like extensibility, input events, and scripting aren't supported, nor are some web-oriented scenarios like external references and hyperlinking. If you need that kind of functionality, we encourage you to use an HTML app or the XAML web view control, both of which come with Edge's full browser-grade support for SVG. OK, let's do another demo. This time, we're going to do something a little bit more ambitious. We're going to drop down to C++, and I'm going to show you how we can use Direct2D to load, manipulate, and render an SVG object on the fly. For this, I'm going to use an app that I've already prepared. In this case, we're using a C++ app, and in its current state, this app does much the same thing that the XAML app we just saw. It's just rendering this smiley face to the app swap chain. Let's take a moment to go through the Direct2D code and show you how it's doing that right now. So this method, create device-dependent resources, is where our app is going to create all the resources that it needs to bind to the graphics hardware at runtime. This is the same place where an app would be loading and decoding images, creating brushes that it's using for geometry, and so forth. SVG works much the same way, so let's walk through loading and parsing this SVG file. Here, I'm using the WinRT asynchronous APIs to retrieve the file from the app package. It's already been added to my assets folder. I'm opening the file for reading, which returns for me an iRandom access stream, which is a WinRT stream object. Now, Direct2D is a COM-based API, so we need to quickly wrap that stream in a COM stream so that we can use it with Direct2D. Next, we pass that stream to a new method in Direct2D called createSVGDocument. This method takes in a COM stream object that contains SVG's XML data, parses that in Direct2D, and returns to you an SVG document object. Now, notice my app doesn't have to do anything with the parsing itself. All of that's encapsulated in Direct2D, so your app can stay focused on the actual creative work of rendering. So once we have this SVG document object, we can use that to draw the SVG file, and we can also use it for programmatic access to the SVG object model. I'm storing this file as a member variable so that we can access it in other methods. Let's take a look down here at our render method. This method gets called 60 times a second by the app's infrastructure. And in true Direct2D fashion, it has a begin draw and an end draw. And all of our drawing code lives between those two. So here, the drawing code is quite simple, making a single call to another new method, which is drawSVGDocument. Intuitively enough, this method takes an SVG document object and puts it on the swap chain. This works much like an image, the drawImage method. So you can provide different offsets and transforms, and SVG is compatible with the full pipeline of Direct2D effects. So just to refresh your mind, let's take a look at how that looks right now. OK, great. But like I said, let's try something a little more ambitious. Let's try modifying this image on the fly. Further down, we have another method here called update. This is also getting called at 60 frames per second, just prior to the render step in our app's logic loop. I have some code that I've already written here that I'm going to go ahead and uncomment. Let's walk through what this code does. First, we're going to retrieve an element from the SVG tree that has the identifier writeI. To do that, we're going to use this findElementById method, which works very similarly to how JavaScript access works if you're working in a browser context. So this is going to look throughout the SVG tree for an element that has this identifier. If I pull up the SVG file real quick, you'll see that this ellipse here has this ID. I've added that myself. Going back to the C++, let's keep going. Our next task, we're going to retrieve two attribute values from this SVG element. In this case, Cx and Cy, which correspond to the x and y coordinate of the center point of that ellipse object. These get loaded into two float variables in C++. Notice that this is a strongly typed API, so your app doesn't have to do any string parsing or other annoying logic like that. We could do anything we want with these C++ variables, but in our case, we're just going to add a little bit to them each frame. Once we've done that, we're going to use the setAttributeValue method to store those values back into the SVG tree. This will make sure that the SVG file is updated, so the next time we draw that SVG document object, it'll reflect the updated SVG tree. We can do other things with this SVG document and with elements, like changing the values, adding or removing children, restructuring the tree. Most of the things that you could accomplish with the browser DOM APIs that you might be familiar with. So, in review, this block of code should retrieve the right eye element and add a little bit to the x and y center point of it every frame. Let's compile and run this app, and if I haven't messed up, we should see something animated. OK, that's a little more disturbing than I was expecting, but I think you get the idea. With just a little bit of C++ code, we are dynamically updating this SVG file and rendering it cleanly at 60 FPS. You could also use this logic to change the colors in your icons based on the user's theme settings, or to implement some animations involving interaction with the UI. That's about it for this video. I hope I've inspired you to check out SVG and try using it in your apps. You've seen how with XAML, you can use SVG images as easily as you could use a PNG. And with Direct2D, I've given you a taste of the power and flexibility that's at your fingertips to manipulate SVG as you will for your more advanced iconography scenarios. Check out our SDK samples on GitHub and our documentation on MSDN, and try out using SVG in your app. And most importantly, keep telling us what you think. Your feedback led us to building this feature in the first place, and your feedback will help decide where it goes in the future. Thanks for watching.